Hi, everybody. It's Friday night. It's 9:39 p.m. The doggy is at my feet. And we are about to embark on another GTT episode. And this is going to be a doozy. We're going to have some fun. I have a strong suspicion we are all going to learn something super interesting. At least that's my hope. So let's dive in. First and foremost, I am listening to my techno music because I really needed it tonight to do this. It's literally playing right now on this guy. Oh, this way. Yep, there we go. There you can see it. It's live. In fact, I'm going to turn it up just a tiny bit. Because some days, you just got to have some awesome techno playing in your ear while you're GTTing it out. So if you see me bobbing my head tonight, that's what's going on. On top of that, we are going to talk about a number of these virtues. First, I'm going to try my best to not judge harshly. Ooh, but it's going to be tough because, well, you'll see. But I'm going to try my best to be fair and logical. Always important for me. I'm also going to try my best to prefer weak claims to strong ones. And the reason for that, well, that's one of our virtues in here somewhere. But where is this? This is actually one of the first things that we teach at Merle. Okay, we have seen this on the list before, right, guys? I thought it was like on this side. Yeah, oh, it was. Yes. Okay, there it is. All right. So what does it mean to have a weak claim over a strong claim? The way that I generally reason about this and the way that we think about this or talk about this in like scientific literature is a weak claim, or to weaken a claim, is to reduce its strength so it's not as absolute. An example of an absolute claim, or otherwise a strong claim, would be something like this. C++ is the best programming language. This is a strong claim because it's absolute in that there's no qualification. On top of that, in many cases, not all cases, but in many cases, people can sometimes confuse opinions as facts when opinions are presented as strong claims. For example, the claim C++ is the best programming language is an opinion. It's not a fact. Because, like, what does that even mean? What does it mean to be the best programming language? Is that the fastest language? Fastest to prototype? Easiest to learn? C++ is definitely not that. It's a lot of things, and I love this language. Keep in mind, this is my language of choice, as you're going to see shortly. But it's got some issues. So to make this kind of claim is not only dubious and likely to lose a reasonable amount of respect and credibility in scientific circles purely based on the audacity of the claim is actually not even that meaningful. Because, like, what does it mean? So instead, we should prefer weak claims. And weak claims tend to take a view that's qualified. For example, instead of saying C++ is the best programming language, one might say the runtime execution of templatized metacode in C++ is more efficient than instantiated parametric polymorphic code in Java, for example. And that might actually be a correct claim. At least in my head, it sort of makes sense. And the reason for that, very quickly, is template code in C++ is instantiated at the moment at which it's compiled, based on my understanding. I just qualified my claim. I just weakened my claim with that little based on my understanding. Because I'm trying to protect myself in case I get this wrong. Because I know interpretable metaphor is lurking somewhere. And he's probably going to call me out if I get this wrong. So in templatized C++ code, I believe that it is instantiated once it is provided a type for its instantiation. What is actually compiled is the code that is synthesized for the types that are provided for that template. Therefore, at runtime, the only code that's executed is the type-specific instantiation of the templatized code that was transformed into type-specialized code at compile time. Now, in Java, or C++ for that matter, as I understand it, another weak claim, the parametric polymorphic code. Oh, am I getting this right? I might be getting okay, let me back up. I might be referring to subtype polymorphism. Sorry. I get these. It's been a while, so let me just back up and let me say what I'm intending to say here is, I think it's subtype. Let's find this out. What's the difference between parametric polymorphism and I think it's subtype polymorphism? Let's see, parametric polymorphism, subtype polymorphism, two different forms. Focuses on writing code that works different types by using type variables, while subtype polymorphism uses a single name for the instances of different classes related by common superclass. Oh, yeah. Ooh, oh, boy. Ooh, this is a doozy. I think I might have been right for both cases in Java. Because I think Java has support. Oh, yeah. Woo, this is going to be a rabbit hole. Oh, man. How far did we go down this rabbit hole? I believe that Java added support for a thing that it calls like templates. But yeah. not specifying concrete type, instead using abstract symbols. Okay. Yeah, so oh my goodness. Sorry. In my head, I'm trying to determine, do I want to go down this rabbit hole? Because it's going to deviate us quite a bit. Let me save us from going down this rabbit hole too far, because I really want to get to some of these other topics. But the higher order bit is there's essentially two fundamental ways to do polymorphism. There's probably more, but these are the two that are invoked the most common. There's parametric polymorphism and there's subtype polymorphism. The parametric polymorphism is, as I understand it, especially with clarification here, it is what we think of for template programming in C++, that we don't supply a concrete type and instead use abstract symbols that can substitute for any type. Template T, and then we substitute in an example of whatever we want. Yeah, exactly. Parametric polymorphism, this list T, a subtype, we have inheritance, right? The way that parametric polymorphism works in C++ and subtype polymorphism works in C++ are different. Parametric polymorphism invokes, essentially, as I understand it, only compile time overhead. It can potentially increase compile time and the code footprint of the binary because it's generating more code. You can have those byproducts. But assuming those don't impact things like cache performance and other things that they absolutely could, because you have things like the instruction cache, right? It's not just the data cache. You also have the D cache and the I cache. So you could, if you have a binary that has too much code in it, code data, then you overfill that cache. But assuming that that does not happen, you essentially elide away performance hits for type identification at runtime when you're using C++ parametric polymorphism. Okay, hopefully that's clear. If not, maybe play that back a couple times. Hopefully I said it correctly. I'm not going to try to say it again because I'm probably not going to say it correctly. All right, now subtype polymorphism is this idea of this. You have a class, and then we're going to inherit from this class and derive these subtypes, right? Now, when you are doing type abstraction through subtype polymorphism in C++, it tends to, maybe always, but I'm not sure. So again, let's weak claim this. It tends to invoke runtime overhead because it will often have to reference things like a virtual table, a virtual pointer, to then infer information about different characteristics of the class. Like, for example, if this has a make sound function, and the make sound function is a virtual function that's in the base animal class, and this is virtually overloaded in both dog and cat, but what the function has received is an animal pointer, and it invokes the make sound function. Then, in order to determine what make sound function should be called, is it dog or cat, it references essentially the virtual, through the virtual pointer, the virtual table, which tells it, do I invoke the base class one? Do I invoke the derived dog or cat one? And so it figures these things out at runtime. While this can be very powerful and allow things like reflection, this can also have performance degradations or create essentially non-deterministic performance overhead? You don't necessarily know because of that vtable lookup. I mean, you can speculate, but I think it's, minimally, there will likely be additional performance, but it's not super clear if that will be constant or not. Whereas in the parametric polymorphism side, there is no performance overhead. And again, we're just talking about C++ here. And this is just to the best of my knowledge. So if you did this as a template and you had a function that takes a type, and in that function you have make sound, and you're not using subtype polymorphism, you're not using inheritance. Instead, you just have a function of this type that has make sound. Then what will happen is it will just call that function. And if you try to invoke this template function with a class that doesn't have the make sound function, or method in this case, it will just say you can't do this because that function doesn't exist. Now, both of these are ways to essentially get polymorphism. One is essentially doing it through this type abstraction. The other is doing it through this subtyping, which we generally call inheritance. Now, to make matters even more interesting, it's my sneaking suspicion, and I don't know this for a fact, and it's been a long time since I've looked at this, but when Java originally got its generics at the time looked and felt a lot like C++ templates, with one major difference, is that ultimately they were still doing subtype polymorphism, as I understand it. And part of the reason for that, I think, is that in Java, every object is an object. And so you can't get away from, because it's a strongly typed object-oriented programming language. And what I mean by that is I don't think you can have anything in Java that isn't a class. Even like numerics, like integers and stuff, floats, even Booleans, I think they're all classes. And I think they all derive from like the object class or something, like the native types. Whereas in C++, there's a large portion of things that are just like, yeah, you're not a class. You're just kind of native stuff. Or at least that's how you can think of the native types. So again, I'm probably getting this slightly wrong. So again, another example of the weak claim part. But as I recall it, this is quite interesting in that even the parametric polymorphism that you can do in Java with Java generics, it doesn't have the performance benefit that you get from C++ in that it elides away any runtime type binding. Because, one, I think of that object dependence. And then I think on top of that, like I think it had something to do with the Java runtime, essentially. There was this other piece to it that it like didn't need necessarily to do the strict type binding at compile time, because Java's compile time system, I think, again, I'm not a Java expert, sort of just binds down to the Java native bytecode, which is an intermediate representation that's going to be later bound down lower to whatever the instruction set architecture is that it runs on. Something like that, right? It's a little hand wavy, but you kind of get the gist. So what's the takeaway? Well, the takeaway is even though C++ and Java both support what appears to be potentially similar types of parametric polymorphism, C++ with its templates, Java with its generics. And again, I know a lot more about C++ than I do Java. Their actual performance implications are different because of the language design. So the claim that I had originally that C++ templates could potentially be more performant than parametric polymorphism in Java could actually still be correct because of that compile time type binding. On top of that, the claim I was actually trying to make was that the C++ parametric polymorphism is faster than, or is likely to be faster, let's qualify that, as Java's parametric subtyping, I think also stands. And the reason for that is due to the vtable invocation and things related to virtual pointers and how you have to do type resolution at runtime for, just in general, for parametric subtyping, but you generally do not have to do this, or you never have to do this for parametric polymorphism in C++. Never is probably too strong, but I think that that's the way that it's designed. Okay, cool. So that was a really long way of explaining the difference between weak and strong claims. Hopefully that didn't confuse every single person listening to this. If it did, I totally blame this awesome music that's playing in my ears, because as I was talking, I got to be honest, 20% of my neurons were just really loving this continuous mix. Strongly recommend you check it out. By minute 40, it starts getting really incredible. Okay, cool. So as we're going and doing a slightly deeper dive on this code, I'm going to try my best to keep my claims weaker-ish than stronger-ish, even though I'm going to be slightly tempted, I think, to make them a little bit stronger. On top of that, we're going to do more of this mastering the basics. And in some sense, we just did. That I think most of us that code in object-oriented programming languages, we know, okay, this is largely speculation, but if you do object-oriented programming, I would argue that you probably have some understanding of what inheritance is. Which, as an aside, I just want to argue that while I have a deep love of OO, I don't love inheritance. I think that the beauty of OO, there are essentially two major beauties of object-oriented programming. I mean, there's probably more than that, but there's two that I lean on that I think make it the way to go for large-scale software design. The first is OO lends itself for interface-driven design. I think interfaces used as contracts tend to be phenomenal ways to write large-scale software. And in fact, I am a strong advocate of what I call interface-driven development. It's not exactly like test-driven development, but it's similar-ish. In that the way I'll code, and I think maybe some of you have seen me code this way on GTT, is I'll start writing code that assumes all the stuff that I'm calling already exists, even though I know it doesn't. And the reason why I do this is I follow like the agile development principles of don't over-engineer stuff, don't write all the code for like your class and all the things that you think you'll need that you don't need. Instead, what I'll often do is I'll just say, I'm going to try to solve this problem. And in the process of trying to solve that problem, I will just write the code that solves it. And in writing that, what happens is I will then invoke the interfaces that I think I need to make that behavior work. This is what I refer to as interface-driven development, is that I'm literally just calling into the interfaces that I need in order to solve whatever problem I'm trying to solve. And there's probably some name out in the world of computer science. Feel free to let me know what that is in the comments. And maybe it's called interface-driven development. But anyway, you can probably tell how this is like slightly different than test-driven development. Is I'm not writing a test that's meant to test that it works or it doesn't work. I'm literally writing the actual solution for whatever the thing is. And I'm probably only writing the case that it's like, this is the good path kind of thing. Like this is, I mean, I'll deal with the errors and stuff, but it won't be done in the way that you might imagine if you're doing test-driven development, which is I'm going to write this, and then like if it goes the wrong way, then it would do this, and if it goes the right way, and I want to like pre-populate all the data and stuff. Like I don't do any of that. I do like this is what the actual implementation should be, and I just call into code that doesn't exist. Then once I have that implementation written, I then build all the interfaces that I essentially called into. And what I like about this is as I'm writing this code, what I've often found is the interfaces that I'm imagining in my head are not super great at first. And so I'm writing the code, then I think, I don't really like this. It's too clunky. And then I could just compress this and do it like this. And so I refine it until it gets to sort of like the right code footprint that matches my intuition on what it should look like. And then after I have that and I look at that code and I think, I like this code, then I build the interfaces for just that. So a big reason why I switched to this versus the other way where I'd like start creating a class is when I was writing the interfaces directly in the class, I would often come up with the implementations that are like version 1 of my interface-driven development, which would work, but it would be kind of boring and be kind of obnoxious. And then I would maybe be too lazy, or I wouldn't be too lazy. I would actually rewrite it, and I would ask myself, gee, Goju, why did you waste all this time writing this bad version 1? Whereas if you thought about it a little bit more, you could just write the good version 2 or something. And interface-driven development, I think, lets me do this. Okay. The beauty then of OO, in my mind, is following this principle of interface-driven development. And you could do this in a non-object-oriented way, sure. But I find that I tend to think of methods as part of systems. I like, at least for me, I feel like the mental model. And by the way, I don't know necessarily that I'm any authority on this. I think there's lots of people that know programming languages far better than I do. And I know some of these people, and they would probably argue that you don't need objects for this, Goju. And I already agree with you. You don't. But for me, I like the mental model. It somehow simplifies things in my head because it gives me containers of where stuff should reside. Like, for example, if I have an object that's a car and I have a start function, the context of invoking the start function on the car is different than the context of the start function that might exist on the blender or the TV or the race object or something, right? So it's like it does the right kind of marrying of type information and operational information where that context makes sense. I like that a lot. Okay, so that's characteristic number one that I quite like about OO. Interface-driven development, using interfaces. And also, you can really lean in on interfaces when you make them pure interfaces, like you can in Java or C++, you set them to 0 or this kind of thing. And then you have essentially true abstract base classes. I think this is pretty cool. And in fact, we might even look at this example over here of some code that I've written and open sourced, trying to show my love for OSS. I think I had some base class. Yep, there we go. That is meant to be something that is like nearly pure virtual. Not exactly, because I've got this name thing, and so I think pure virtual is like there's no actual constructor. So clearly I don't really fit that, but I am I'm defining interfaces here that are virtual, and I'm explicitly not defining them because I'm saying that whoever derives from this, you must implement these. I'm not going to give you a base implementation, not because I can't, I could, but it would defeat the purpose sort of this this design. This is, I think, challenging to do in non-object-oriented programming languages. I say challenging because I suspect, again, the procedural folks are out there in force and can probably show me how you could do this without classes, and they're probably already right. I already agree with you guys. Thank you for proving me wrong. And then the functional folks probably will come up with something clever as well, and I agree with you guys too. Okay. I just find that this is super useful and has a really nice mental model for me. That's characteristic number one. Characteristic number two is this: data encapsulation. Data encapsulation, the idea of essentially hiding data, like this variable, behind this protected or private in many cases, is one of the most incredible ways, in my mind, to enable systems that otherwise would likely be very challenging to scale to large-scale software systems in a way that is significantly simplified. What I mean by this is if you use data encapsulation inside of objects the way that it's intended, or the way that I interpret it as being intended, meaning you're hiding it behind things like protected or private, because you're not trying to share the implementation details, which is a big aspect, at least for me, of OO, then this allows the software to be notably more modular and dynamic in its evolution as things change, as they almost always do, as you move toward large-scale software systems. And believe me, I have done massive refactoring, redesign, re-whatever we're talking multi-million line software systems. And I have had to deal with this in systems that do not properly support data encapsulation. And it's a nightmare, or it was a nightmare when I was doing it. And then I've also done it in multi-million line pieces of code that do properly support data encapsulation. And that has been enormously, I mean, we're talking 100x type of my life is easier. Because when you have to refactor the actual implementation, as you sometimes do as things scale, because suddenly a stood string is not sufficient, you need to do it something else, you oftentimes can get away with not having to change a lot of things. In this particular case, you might be like, well, you have this interface that's doing this, stood string. Okay, sure, I agree with that. But the implementation of this could be something other than stood string, and then we could convert it and do a copy. And in fact, this is probably the reason why I did this stood string as a copy, not as a return by reference, specifically with this in mind, truthfully, because I understand references, right? I'm using them in cases where I think references should be used, although admittedly I didn't use one there. So who knows? Maybe that was me fat fingering it. If so, I screwed up. Add it to the list of things I don't get right. Or maybe this is a sign of genius and I was intending for the conversion not to be exactly right. And that's why this is returning by copy. Although, again, the counter argument to that is it still doesn't excuse the case of not using this as a const ref. So, bad Goju. Anyway, back to the point that I'm really trying to make, which is data encapsulation, when done properly, like, again, in here, can help you in ways that I can't even begin to describe as you start to scale the size of your software system, and you need to make it significantly more robust. This thing is a lifesaver. And I think probably one of the things that makes it the most maybe strange is that until you've built extremely large-scale software systems and you need this, you oftentimes don't, or you may not have the wisdom or insight to understand just how valuable it is. That was certainly the case with me. When I first created Notica, it was all in C. I didn't do data encapsulation at all. And then what I realized along the way is I needed to redefine the way the core character traits for each character worked. This is like strength, dexterity, agility, constitution, willpower, speed, wisdom, intellect. That's actually all of them. Yeah. I needed to redefine the way that those are going to work for reasons outside of the scope of this discussion. The way I originally designed it is those data were exposed directly to the code that would access it. Like you would just read it. You would just be like, here's the strength. Here's the access to it. This was really problematic because I wanted essentially to have it be behind an interface because I was going to do complex calculations that needed to be applied in certain contexts and needed to not be applied in other contexts. But because I was accessing the data in a raw state, it wouldn't work this way. So what I had to do is I had to go through all of the code and change all of the cases where this is just one of many of the things that I learned, to have it just be something as simple as, instead of accessing strength directly, just call the strength function. Literally that simple. Again, the details of this are outside of the scope of this, but just understand there were different contexts that were happening in the game that would change the actual value that you would get. Like maybe some super event is happening in the world and everybody got stronger, right? Or maybe it was a case where just the monsters get stronger. Maybe just the players get weaker, right? So you can imagine some weird global state having this effect, and you don't want to just give the strength value. You want to be able to reason about the context and say, oh, based on this, I'm going to give you this different value. Again, data encapsulation. It allows you to do really awesome, wacky things. And so what I ended up doing is I just had to refactor all the code. And at this point, we're talking hundreds of thousands of lines of code. What made it even worse is one would think, well, it's so easy. Just do a find and replace for strength and dexterity and all this stuff. Oh, if it were only that easy. There were plenty of cases in the code where the word strength or the variable strength existed that had no binding necessarily to a class. Yes. And so it wasn't necessarily as easy as just this simple pattern matching. Again, you might argue then, well, just use the regular expression thing and try to make sure it's preceded by something. Many of these techniques could or could not potentially work. The takeaway is that if you just use data encapsulation the way that it's intended to be used from the get-go, it allows inherent modularity aspects in your software. So when your software design needs to evolve, and believe me, if you write software systems that get used by a lot of people, and by a lot of people, I mean hundreds of thousands or millions of people, and those systems scale, more likely than not, your software is going to need to evolve in ways that you haven't even begun to imagine yet. And that's a good thing. It's actually a really good thing. It means that the stuff that you're building is being used, that people like it. And so we shouldn't discourage against this. In my mind, we should encourage it to go in this direction. It's like one of the shorts that I just did, which is I'm of the strong conviction that software tends toward entropy. And what I mean by that is, as you have a software system and you grow that software system, it tends toward more chaos because there's more stuff. Like, it usually is not the case that, hey, this software system is great, but you know what would be fantastic, Bill, is if we just reduce the number of features, cut them in half. Like, very rarely there are some cases like this operating system or, some other stuff where they could maybe use to remove a feature or two. But like, for example, with Mentor, usually what we hear with Mentor is, oh, we love Mentor. Mentor's so great. But, wouldn't it be great if you supported COBOL? Actually, we got that at IBM Think. Do you support COBOL? Do you support RPG? Oh, that's cool. They have this new, that's pretty sweet. They have VHDL in here. This icon is new to me. That's fun. Wonder where Sysverilog is. Anyway, yeah, clearly I'm like the dog with two sticks, and so I just dropped that. Anyway, back to the original stick. People are usually asking us for more features on. Whoa, did they fix this too? Woohoo! Wow. Yep. My team, they are rock stars. Again, this is realware because the last time we showed Mentor, especially incubating, you remember the icons being like super big, and I was saying, oh, they did this refactor with the UI, and so they don't quite fit. I know Mur is what, and Taylor, I know that you know. So this is the same repo, right? It's still this, and now they've got it fixed. They've got it resized properly. So good job, team. High five. Excellent. Yeah, so more features like that, more features like this and stuff. This is why software tends toward entropy. And in order to combat that, because if the entropy goes too far, what I've seen time and time again, and I suspect this is going to happen with whatever this vibe coding shenanigan thing is. At some point, I'll get into this, but not today, because that's going to be like a 10-hour VOD. VOD. It's like a 10-hour VOD. And it's not just me, by the way. There's many other people that are far smarter than me that have some major reservations with this thing. It reminds me almost of like what is it? It's like the NFTs, the non-fungible tokens. And like there was this thing, right, where people were losing their minds over these NFT things. And in my mind, like someone that has built internet software for 25 years, and I have virtual goods on Nautica. I understand virtual goods system and uniqueness of virtual items. In fact, some of the most expensive and extraordinary items in Nautica are the virtual unique ones. But it's important to understand that that is related to the context of Nautica, is that unique sword is valuable because it has properties in the context of the game to do incredible things. It's not a universal object that anybody wields it, like in World of Warcraft, they suddenly become superheroes. Because these things don't necessarily have universal value. They have more like contextual value. You know? So anyway, sorry, I'm just going down the rabbit hole about how this relates potentially to cryptocurrency, because I think that was maybe the parallel. Anyway, so you had this NFT thing going, and there was this huge ordeal about how this is going to change everything. It was like the new cryptocurrency or something like that. And a lot of people invested a ton of money on this thing that to me looked like hypey nonsense. And I'm not saying that because I'm like a curmudgeon anti-technology. I'm literally the opposite of that. But it just didn't make sense in my head. I would try to reason about like, why would someone pay $1 million for this thing that they're saying is this unique identifier when I could just replicate that thing myself, and then now you have like two of them. And who's to say that mine isn't as cool as yours? It's just because you gave it some sort of ID, and like it's just an image or something, right? I'm confused about this. It's different than cryptocurrency in that does have a binding to this economic system that does make it unique in some capacity. That if you replicate the Bitcoin signature or something for this wallet in something else, it doesn't have the same value because that's specific to the context of Bitcoin. It doesn't have like the same value in Ethereum or Dogecoin or whatever other thing, right? It's mutable. It's not an immutable property. So the same with these NFTs in my head, is that they would have value over in this thing, but then if you tried to have it be like a universal thing, you could just sort of like replicate this, and then who's to say that this other version, right? Because it's not a constrained system. What's the point in all this? Where are NFTs today? I have no idea. All I know is that they somehow just maybe did not do something super cool. Let's actually take a gander on this. What happened to NFTs? The NFT market experienced a significant decline following a rapid boom in 2021, primarily due to a combination of market saturation, the death of the hype cycle, no doubt, and issues related to copyright and authenticity. Right, it's that authenticity part. Like you could just replicate it, right? Okay, while NFTs are still traded, the overall market has shrunk and transitioned toward more practical applications beyond purely speculative digital art. Yeah, it just like you could just replicate it. I don't understand. It's not like you have a Picasso and it's a physical thing, and then you could do all this various stuff in the physical world, right? And again, with the Bitcoin example and cryptocurrency, they're bound to the specific economic market where the coin has a perceived value. That if you then try to just transition that to something, it like doesn't have a universal thing. And if you replicated it outside of this constrained space, which is fully secure, and the place where people are like doing the trading, then like it has different value, different meaning. And I think that this is maybe one of the fundamental issues that I saw with the NFT market. Again, not an expert in this, but yeah, here we go. This is great. Initially pitched as a new class of investment asset. By September 2023, one report claimed that over 95% of NFT collections had zero monetary value. I mean, like, yeah, just think about it for a second. Like, that's okay. Sorry, I'm probably doing a little of this, and I like I said, I do it sometimes. I don't mean to do it, but this is how I feel about vibe coding. It's like the NFT thing. I think about it, and then I think, really though? Like, it just doesn't make sense to me. So you have this system write all this code, and then the code isn't perfect and needs to be fixed. Who then will fix it? The people that didn't know how to write the code, that needed the vibe coding thing to write it? Well, they can't because they can't code. Okay. What about the vibe coding machine? Well, if the vibe coding machine was sufficiently complex and awesome, it wouldn't have written the bug in the first place. So that's out too. So who's left? I don't know, the people that can actually write code? Yeah. So they fix it. Now, in some sense, if you go down this rabbit hole a little bit further, it actually seems to imply that coders become more important, not less important, with the presence of vibe coding. And I think that that's actually correct. I think that vibe coding, assuming it remains a thing, will actually precipitate an incline in the need for software developers to maintain the volume of not great, this is me being super generous, not great vibe code synthesizers that the people who were asking this to be built can't maintain themselves, and the systems that are actually generating it don't actually understand it in a holistic way to be able to modify it or extend it. And this is coming from someone who I have a fairly seasoned, I think, understanding of machine programming. Have been working in this space for quite some time. And there are certain complex things that start to arise when you are going from a software system that exists and you're trying to extend it versus a software system that does not exist and you're just trying to create it. So maybe think on this for a second. This can be an exercise for us all to do at home. Is it harder to build a system that will generate something from scratch, or build a system that will essentially generate the same thing, but instead of from scratch, it will do it within the constraints of an existing system, and that existing system can change from embodiment to embodiment. I think, the way I phrased it, it kind of gives it away, but this is often the reason why people like to code things from scratch. It's just easier. You don't have to think about all the stuff that you've got to make it work within and this massive code base that you can't break. And so in some sense, the vibe coding thing, while cool, again, prototypes, I've said it before, I'll say it again. Building rapid prototypes that may not have real commercial value, but can quickly demonstrate some form of ideation, great area for stochastic language models and the vibe coding assistance. Absolutely. But in the real world, where we have software systems that actually are not one-offs, but they need to be maintained and they need to be improved iteratively. Thus, one of the main reasons why we built this thing is I'm far more interested in this problem and dealing with things like 2 million lines of code and being able to reason about these massive software systems and then hone in on millions of lines of code and say, yeah, this one line here out of the 2 million, this could be written in a slightly better way. Yeah. And by the way, I think that just in this very quick assessment, I haven't deeply analyzed this. I think that Mentor's both identification of this and potential simple rewrite of this is probably an improvement. Yeah, in both these cases. I'm just trying to figure out. So this is This is a simple range check. But this is... I mean, it has the appearance of transitioning from being fully lowercase to being an uppercase. But yeah, I'd need a second to actually... Usually what is done is it's two sets of ranges. It's the range from lowercase a to lowercase z, and to uppercase a to uppercase z. And this does not appear to be that, which is also, I think, maybe a reason why Mentor wants this to be rewritten. Yeah. So anyway, as someone that really loves code and doesn't see it as maybe like a nuisance, something to get beyond, is, I think, fidelity of code is quite important, especially as we're building larger and larger software systems that are critical to the future of society, which may sound a little bit extreme, but if you think about it for a second, almost all domains in the world now are in some ways run by software. And I'm not saying this like in a hypey way. I'm saying this like in a real way. And keep in mind, I'm not saying that this is AI. I think AI has value and we're going to explore it. And I think it's going to be highly successful in some areas. Other areas, I think that it's probably going to not be super successful. And there's a lot of iteration. So AI aside, I'm talking specifically about software. When you look at almost any domain that exists in the world today, I tend to find that software plays an increasingly large role in whatever that domain is. Stock market, software probably plays a bigger role today than it did 10 years ago. Agriculture, software, again, today, bigger than 10 years ago. Then you have things like the internet, right? Like that one's pretty obvious. But even things like our TVs, 20 years ago, maybe we got to go back further than that. 40 years ago, software, I don't think any of the TV manufacturers thought that software would matter at all for TVs. It's like, that's not going to affect us. And now today, good luck trying to buy a TV that's not a smart TV. I don't even know why they call them smart TVs, because they're all smart TVs. It's just an extra word. You can just drop the word and just call it a TV at this point. At least that's kind of the way I think about it. It's like calling it a smartphone versus a phone. Like, what phone is not a smartphone? What, we just have an extra word. Like, do the opposite. Call it the dumb phone versus the phone. Because if 99% of the market is saturated with the longer one, like, let's just make it easier. Yeah, I have some kind of fun, nerdy thoughts about that if we go down that rabbit hole too far in terms of renaming certain programming languages. So instead of calling it C++, I think we could call the original C something else. All the C people that used to watch this channel have now like permanently banned me. So, okay. I take it back, guys. I love C. I understand the roots of the C programming language, and I was not in my mind imagining that language should be redesigned as this, and C++ should instead be renamed to just this. That's not at all what I was thinking. Okay, so evict that thought from your head. Stop. Okay, Don't question my intentions. Foster goodwill, people. Okay, look, we've been going on for an hour and we haven't gotten to the simple Mercedes code example. So let's do that. And then let's end this episode of meandering, and maybe I'll follow up with another one where we can go into great detail on this Mercedes code. But I wanted to share this with you because, as I've mentioned many times, Mentor currently looks at all control expressions. And oftentimes what we find is that when it finds things in control expressions, it's usually things that are related to if statements, right? Because they're the predominant sort of troublemakers for people doing this stuff that not the right way or could be done in a better way. And Taylor was actually asking me about this, saying, does Mentor actually identify issues in control expressions that are not in if statements? And I've said to him, oh, yes, it does, and it can. And he asked, why is it then that I don't see more of Mentor flagging things for like for loops or while loops? And my response to Taylor was, my speculation is that most of the time when people are writing loops, there tends to be significantly more care that the condition clause, the control expression, is sufficiently simple. Because if they're wrong or there's a bug, it could potentially break over many iterations. It's not just a single path. It breaks everything. And because of that, there also tends to be far more scrutiny when people are analyzing for loops because they understand the magnitude of the iteration. Whereas if statements kind of be like, well, this could be simpler, but you've got 200 if statements, so yeah, whatever. I would abstract out the literal here, but if you want to leave it 1024, okay, you do you kind of thing. But when they see this on this for loop, they instead are saying, whoa. Okay, you've got some complicated thing going on here. Nobody understands this. This is, what is this? This, you're doing something interesting. I think this should be a function. And so I wanted to share this as one example of something that Mentor found because it does identify all control expressions. And this one in particular I thought was quite interesting in terms of a good example of a control expression inside of a loop that I think is too complicated. On top of that, what makes, I think, this example even more interesting is that this code base is quite good. As you can see, based on what Mentor is saying, this is an excellent repo. It's written in Java. It's from Mercedes-Benz. I have no idea what this thing does. And the reason why we're talking about Mercedes-Benz code is we're actually starting to work with them. And so we're analyzing some of their repos. And I do think that this code is generally pretty good. But you'll also notice that there is some interesting things happening. Like, for example, back at this point, there were 30 anomalies, and I'm just going to hit the forward button just once, and you'll notice that it jumps from 30 issues to 86, which is not a small jump in my mind. Let's pause this for one moment. I'll be right back. Okay, we're back. And look, we got this guy. All right, so what were we talking about? We are talking about a big jump on the... He's trying to get frisky with me. On 30 anomalies in, what is that, June 2024 to 86 anomalies in the end of July. Just, hello? What just happened? There we go. Yeah, just 45 days. And the code does increase from 246 to 269. So that's, 23,000 lines of code. So that's a non-trivial amount, but this is not a great jump. Now, all that aside, the thing that I wanted to really hone in on in this particular case is we got a couple other ones down here. I think what Mentor doesn't like about this is it really doesn't like, and truthfully, there is potentially some argument for, like, you might be thinking, if you're an expert coder, well, Mentor's being a little pedantic here. Like, is that really complicated? I don't know that it's necessarily about the complexity here. Is that Mentor is also, because it reasons about semantics and it understands certain things. There is, if this is in a hot loop, and this is potentially called millions of times, just pretend with me for a moment. Why do you have two function calls that are called in sequence of each other inside of the conditional clause of a for loop that is more likely than not static? I can almost guarantee you this is a static number. Almost, because I have seen some cases where it changes. But if we click on this code and we look at this, maybe it changes. My speculation is it's not. Okay, you okay, buddy? He got a little bit of sometimes he thinks he's a cat and he gets the fur balls, the hair balls in his throat. You okay, buddy? Yeah, okay, you're good. Okay, so I speculate, not trying to be judgy here, but I speculate that this is just laziness. And maybe not so bad. Like, again, if this isn't called that much, probably not a big deal. But storing this in a constant and just referring to the constant, yeah. If you care about performance, it's a little bit extra code, but it also is in some ways more semantically clear. I'm picking away at his, there we go. He just had a little thing. It's also semantically more clear that you're not calling this an iterative number of times, because this could change if you pull it out. And so it actually makes the intention of the code, in my mind, more clear by abstracting this away. Anyway, that's not what I care about for this example. I care about this one. Okay, buddy. Okay, what are you doing? And so I haven't looked deeply at this code, but I will tell you that I think that this has sort of no business. My speculation is that this is unnecessarily complex, and this should be abstracted out into something that is more meaningful. I mean, the thing is, if you're going through all these links to create really clear function name descriptions, and by the way, I'm not making fun of this at all. Calling this function create human readable bytes length description is super cool. I think that it makes it really clear what it is you're trying to do. So apply that same mechanism to this craziness, because this, I speculate, is a bit mask. And it means something very particular. I don't know what that meaning is, but I suspect whoever wrote this code does. And they could tell us, and then they could probably create a function name that properly articulates what it is that this thing means, and then we're all better because of it. Okay. Now, while I was looking at this, I was thinking to myself, how could I present this in a way that might be more interesting than just the bit mask? And it dawned on me that I haven't really gone too much into number theory and bases of numbers. But I mentioned, I think, before that we tend to think in terms of decimal because most of our number systems that exist in the real world, like for money and when we count and we give ourselves ages, things of that nature, the days on a calendar, the numbers on clocks, they tend to all be restricted or implemented using a base 10 number system, also known as decimal. But as you start to learn more about numbers and number theory, what you start to learn is that numbers and number systems don't need to have bases of 10. And in fact, in many cases, a base 10 number system is suboptimal because it doesn't have natural corollaries to other number systems. And so for this example, I thought maybe I'll explain this concept a little bit more. So one of the things that you often learn when you're first doing computer science is this notion of binary. Many people know binary just because it's a popular sort of like meme or thing that people say. And now it's overloaded and used in the world outside of computer science. But there was a while there where people would kind of just be like, yeah, computers, they talk in binary. It's all ones and zeros. And maybe they knew what they were saying, maybe they didn't, but it was a cool thing to say, right? And then it started getting overused, and now it's used in sociological circles and causes a lot of debate in things that have nothing to do with computer science. I won't even mention what those things are. Okay. Now, we know that computers, especially transistors, function very well in the space of binary because of the on and off signal for the transistors, as we discussed. And as we also discussed, we pretend that it's digital, as I was just discussing with Paul and Taylor earlier today, that it has this digital perception, but in truth, it's actually analog. But because it is binary, and that's the base level of the computer system, we also have number systems that we like a lot that are related to binary that are not decimal. And one of those number systems is hexadecimal. And as we discussed, I think, in one of the earlier episodes, usually if you see a number that starts with this, 0x, this indicates you're about ready to see a hexadecimal number. And again, this is Java. I'm not an expert in Java, but C++ and C have this mechanism as well. At first, I didn't, and I still don't know exactly what this L means. I speculate it stands for long. And on top of that, because I understand hex, I also know that L is not a valid character for hexadecimal. It stops at F. 0 through 9, then A to F, because that's the 16 digit range. Okay. So what does hex have to do with binary? Well, Hex is a base 16 number system. Binary is a base 2 number system. It turns out that 16 is 2 to the 4th power. Am I getting that right? 2, 4, 8, 16. Am I doing that right? Yeah. So 2 to the first is 2. 2 to the second is 4. 2 to the third is 8. 2 to the fourth is 16. I think I'm doing this right. It's much harder to do live with no calculator. Trust me. Try it sometime while you're being recorded. Okay. So if it's 2 to the fourth, and that's hex, well, then how is that helpful for us in terms of bit masks and thinking about this nonsense? Well, turns out very helpful, because when you know that hexadecimal is a perfect transition from binary to hex, which decimal is not, because 2 to some power is not equal to 10, but 2 to some power is equal to 8 and is equal to 16, which is why we tend to care about octal and hexadecimal. Then it gives you clues about the shape of things, the geometric space of things. And so what does this mean? What this means is that when you think about binary bit masks that you tend to get into with these types of numbers, you can think of each digit, and by digit I do mean things that are alphanumeric, not just numeric, alphanumeric. So in this case, the F and the C. But each digit is a representation of 4 bits. 4 bits. 2 to the first, second, third, and fourth. And therefore, without knowing these numbers at all, I can tell you that the shape of this hexadecimal number will have the topmost 12 bits that are of an identical shape. And simply because I know what the F's are, those are going to be all ones. Just be straight ones. Then all of the rest of the, I think they're called nibbles, half a byte, 4 bits. Each of those will then also have the same shape because they're all C's. And this is one way that you can start to have mental mappings without ever knowing exactly what the binary representation is, but to understand the breakdown of the space when you see something that's in hex and you're mentally converting it to binary. This then can be really helpful for you to be able to sort of visualize and do like a mental interpretation of whether or not some sort of hexadecimal number has the right kind of mapping to a binary number. And an example of that is this one right here. So here's this hexadecimal number, and I put it into our programmer calculator, and you can see that here's it in hex. Yep. Here's it in decimal. Who knows what that means? Here's it in octal. There is some corollary with octal, which we can get into at some later point. But here it is in binary. And as we were mentioning, the top 3 nibbles, I've got the dog on my lap, but hold on, let's see if I can still type here. Okay, chill out, buddy. Okay. in computer science, what is a nibble? Okay, perfect. So just so you guys don't think I'm crazy and I'm inventing terms, yes, don't ask me how I know these silly. Does anybody even use the term nibble? Okay, so now you know. It's essentially it's half a byte. Okay, let's go back to this thing and this thing. So what we learned without knowing what this hexadecimal number means, what we learned is that the way that hex works, because it's 2 to the 4th power, and because binary is a base 2 number system, that it will take up 4 digits of space in their representation. And that gives us a very simple way of doing a mental mapping of what the bits will be set to for any hexadecimal number. And in fact, now that you know this, it may become super clear why, when you see hexadecimal numbers in code, it almost always, not always, but almost always implies it's a bit mask. Because those numbers can be represented more efficiently in hex than they can be in decimal. And they more clearly represent to a fixed range of bits, the nibble, for each numerical representation in hex. In this case, you have, what is this? It's 15. I think it's 15. Is that right? 15 digits? Hold on. 4, 8, 12, 13, 14, 15. Yeah, it's 15 digits. And so 15 digits means 15 nibbles. And the data point that's somewhat relevant here is that 15 nibbles is 1 nibble short of the 16 number, which then, sorry, I'm really rabbit holing here. Hopefully this makes sense to at least one person watching this. 16 nibbles is 8 bytes. And 8 bytes is a 64-bit numeric system. And that's what's going on. Now, if all of that didn't make perfect sense, if you want, you can just play this on repeat and then maybe it'll make sense. If it did make sense, that's super awesome. What's so great about recording these is I don't have to say it again. I just know that you can hit the rewind and play it again. But my hope is that we all learn something at least kind of cool. Like if you knew about the hex translation to binary, that's great. Maybe you didn't know what a nibble was. Maybe you did know what a nibble was, but you didn't know that the hex does a translation directly into the nibble because of the hex being 2 to the 4 bits to represent 16 possible unique numbers. And then 2 to the 4th is essentially half the size of the byte, which is why, again, the programming calculator breaks it down this way. And then if you knew that, maybe you didn't know that Mentor can actually find issues and control expressions that are part of iteration. And if you did know that, maybe you didn't know about how terrible NFTs are. Well, okay. I mean, that's an opinion. Maybe they're not that terrible, but I don't know that I've seen value in them. But maybe you didn't know about all this cool stuff on parametric polymorphism and subtype polymorphism. In fact, I think I knew, but I forgot exactly. I think I was getting them confused. And so this is minimally even helpful for me as a reminder. Okay, we've been going for a while now. The dog is getting a little anxious. And I want to wrap this up. But overall, I have to say that this Mercedes code is pretty good. I'm actually pretty impressed. I am kind of curious about what happened here to make this jump. They do have a leap in the code, but this is quite unusual for them to make this leap. So maybe in our conversations, we'll try to ask them, what happened? Dog, what's going on here? Like, I almost wonder if it's like a new code member. Yeah, maybe a new feature or something. But yeah, really cool stuff. And let's prefer to use weak claims to strong ones. And let's continue to master the basics. Again, I've said this many times, but I'm a strong advocate of mastering the basics. And I think most of the stuff is basics. And it's crazy because I think when you get into code that looks like the code we were just looking at, I think people will often look at this and think, whoa, this is so complicated. This is like way over my head. I don't know what this is actually the basics. Oh, and I wanted to share one other thing while we're scrutinizing this. I think in one of the episodes I mentioned that there tend to be 3 numbers that are special numbers that I would deem as acceptable for use in code. Those numbers are 0, 1, and -1. And there's many reasons for this. By the way, 40 is not a special one. This is, I don't know what's going on here. Okay, now the dog's kicking me. More pets, I think, is what he's asking for. He's like, this isn't even appropriate. He's like, sprawl. Yeah, buddy. So 40 is not a special one. 10 is not a special one. 0 is, but a reason why -1 is a special one is for a case like this. I'm not trying to be Mr. Pedantic or like over the top, but it's actually more efficient for this expression to be represented as I is greater than -1 than it is to say I is greater than or equal to 0. And the reason for that is actually pretty simple, is that greater than or equal to is 2 checks. It's a check for greater than, and then it's a subsequent check on equal to. So generally speaking, you should prefer greater than or less than over greater than or equal to less than or equal to. It's very similar to you should prefer equality over inequality. If no other reason, then it simplifies the mental tax of understanding the code. Similarly, I think it also simplifies the reasoning of the code. If something is less than or greater than versus less than or equal to, I think this is an opinion. I believe that it's easier to reason about because you don't have to include equality as one of the conditions. It's just inequality. And so it's either greater than inequality or less than inequality. But when you include the equality, now it's 2 things. So that's the first piece, is the mental tax, I think, is elevated when you do greater than or equal to or less than or equal to. But on top of that, it actually tends to result in an additional comparison operation, which is the equality check. And so simply making a change on this from I is greater than or equal to 0 to I is greater than -1. It's the same thing. And oftentimes this is not done because this is unsigned. And so comparing an unsigned integer with a signed integer is a signed, unsigned integer mismatch. But in this case, because this is very clearly a signed integer, otherwise you wouldn't be checking to see if it's greater than or equal to 0, because if it was unsigned, it must always be greater than or equal to 0, right? Therefore, it must be signed, and so you can just check to make sure it's greater than -1. And then it simplifies things. You don't have to do both these checks, and then it's very clear that you're just checking to make sure that it's greater than -1. So there you have it. Okay, well, my hope is we all learned a little something and had a little fun. Hope it didn't come off too preachy, but maybe I did a little bit at the end. And I've got some other goodies that I want to discuss. 2 more GTT episodes that maybe drop in this weekend, both of which I think are pretty exciting. One in particular, I think will get all of you super razzed, but no spoilers. Okay, everybody have a great night. GTTers or Jeters, party on.